We are now starting a new chapter, chapter 5. Chapter 5, the best way I can describe it is chapter 5 takes all of the kind of oddball functions and throws them all together into one section and then goes through our calculus skills with them. So we will still be deriving, we will still be integrating. However, instead of working with all polynomials or radicals or trig, which has been our focus to this point, we're going to look at things that are logarithmic or exponential, or we're going to look at some inverse trig functions. If you're a fan of the old Rudolph the Red-Nosed Reindeer, the claymation show, there's the Island of Misfit Toys in that. And in my mind, I think of this chapter as the Island of Misfit Functions, because it's truly like, let's take all of these random functions that aren't used quite as often, and let's just throw them into one chapter. And so what you'll notice is one day we'll take one of those oddball functions and do a bunch of derivative stuff with it, and then the very next day we'll turn around and integrate. So you'll kind of see that go hand in hand. So the first oddball function that we're working with is natural log. There are a lot of logarithms that you learn about in Algebra 2, but the one that gets used the most in calculus is natural log. So that we're going to dedicate an entire day of deriving and then another day of integrating just with natural log functions. This video is going to be kind of a prelim type video. This is not going to get into the calculus. This is going to remind you of all the things that you should have learned back in Algebra 2 about natural logs. So the first is the way that we write a natural log is with an ln. So you'll have ln x. It's a button on your calculator with the ln. The graph of natural log I actually put on the screen so you could take a look at it. You don't need to know exactly what it looks like, but you should have a general idea of the shape. It is a very slow growing function. Natural log does increase, but incredibly slowly. Its domain is everything bigger than 0. So I can take the natural log of any positive number, natural log of 5, natural log of 2. I can't take the natural log of 0 or anything below 0. My range is everything. My natural log graph does extend everywhere down below and up above, just very, very slowly growing up above. As far as the look of the graph, it is always increasing, meaning that it has a positive first derivative and has no extrema. It is also always concave down, meaning it has a negative second derivative and no points of inflection. And you can see all that from the picture. And then the last piece is we do call natural log a one-to-one function, which means not only is it a function, it passes the VLT, the vertical line test, but its inverse also is a function, so it passes the HLT, or the horizontal line test. The only point on natural log that you should be comfortable with is the 0.10, and that's because the natural log of 1 is 0. Any log of 1 is 0, and it's one of the basic log properties that you should remember. The inverse of natural log is e. So when we talk about ln and think about its inverse, we should immediately think of the e, the exponential function. In this chapter, we're going to do a little bit of both. We're going to start talking strictly about natural logs, and then we're going to switch gears and talking about exponential or e functions. Because they are inverses, you can simplify them very quickly. E and ln will cancel. So if I ask what e to the ln of 10 is, the e and the ln cancel, and you end up with just the 10. Same thing if it was the natural log of an e, that cancels, so the natural log of e cancels, and you end up with just 4. You can, let me go to Delta Math real quick. You can do some more with this, so I just kind of show you one of these. That one we already talked about. We talked about that one. I don't want to do something that messy yet. Something like this, you can rewrite that as the natural log of e to the negative 2/3 power, because it's in the bottom and it's being taken to the second power, the third root. And so you can cancel that and get just a negative 2/3. One specific one I want to talk about. This one, you can rewrite that as e to the 1/2. So you can do natural log of e to the 1/2, and then you can cancel the ln and the e and get 1/2. Let's see. There's one other thing I want to talk about, and I wanted to see if it showed up here. This one. So this one, you should know that e to the 0 is 1, so you get the natural log of 1, which is 0. So again, we kind of have those things go hand in hand. The other thing that you should be comfortable with is you should be comfortable with log properties. So let's talk for a second about log properties. There are 4 log properties you should be comfortable with. Now, these properties work for any log. We're going to specifically talk natural log as I'm writing them, but I've actually noticed in Delta Math they kind of just do like a common log instead. So our first log property is that the log of 1 is 0, and that makes sense because anything to the 0 power is 1. Keep in mind, remember how natural log works. It's a logarithm that has base e. So this is saying e to the 0 power equals 1. That's why that property works. We have our product property, which says if you take the natural log of two things being multiplied, we can expand it with addition. So we get the natural log of A plus the natural log of B. We have a quotient property of logarithms, which says if you take the natural log of two things divided by each other, you can expand it by doing the natural log of A minus the natural log of B. And I promise these things will help in a calculus setting. I'll show you some basic problems too. And then our last property was a power property, which said that if you have a natural log of something to a power, we'll just call it this n power, you can bring the power to the front and it becomes the coefficient of your natural log. All of these properties have its roots in exponent rules because logarithms and exponents go hand in hand. So when you're looking at this and saying, well, I wonder why we expand multiplication with addition, it's because when you're multiplying bases, you add exponents. So all of these are kind of exponent rules written a little different way. So I'm going to have you practice just some basic logarithm properties because they do make calculus easier. So with our logarithm properties, you're going to see something like this, where you're going to be asked to expand. One thing I noticed, as I said, they tend to do all common log in Delta Math, which is fine. It's a little easier to write, but the properties don't change. So when I expand this, I'm going to pull apart the 6 and the x to the 5th with addition, and then I'm going to bring the 5th power in front. So my answer is going to be the log of 6 plus 5 log of x. And it will show you in multiple steps if you need it. So it'll show the addition first, and then it'll show the power in front. If it's all being multiplied, it's all going to be pulled apart with addition. So we're going to have 4 log of x plus 5 log of y. So pulling it apart with addition and power rules. Look at some that are a little harder. So if you have things being multiplied and powers and division, you got to pull it apart, and it might help to do it a little bit at a time. If you're really comfortable with it, you can do it all at once. So you'll have a 2 log of x because that's your first piece. And then you're going to add that. So your power of y is the 5 halves power because 5th power second root. So you're going to add that to 5 halves log of y. And then you're going to subtract what's in the bottom because it's being divided, log of z. So those are some of the things that you're going to be asked to do for expanding. Expanding is going to make the calculus so much easier. So you'll actually see that skill practiced a lot. You're not going to see a ton with condensing, just because it's not going to be as needed in calculus, but I will show you one. When you're condensing, basically it's like you're putting it back together. This one always makes me think of Humpty Dumpty. We pulled it apart, now we're putting it back together. So my d is going to be taken to the g power. So you're going to have d to the g power. And then you're going to be multiplying it because you have the addition by q. If it has subtraction, let's see if I can find a subtraction one. There we go. If it has subtraction, you're going to write it as a condensed log with division. So this one's going to be d to the 6th. And then you're going to divide by k cubed because it is after the subtraction sign, meaning it is being condensed with the quotient property. So that is quick rundown of basic things you should know about logarithms. You should also know where the button is on your calculator. We won't use it that much. Most of our problems will be non-calculator, but you should know how to take the natural log of something that maybe you can't figure out in your head or it's a decimal. And you should know just basic workings with natural log in general.